Cerebral hemispheres from the cerebrum. So you have your left and right hemispheres. Your lobes consist of the frontal lobe, just like in the skull, the parietal lobes, left and right, your occipital lobe, which is on the back, and then you have your temporal lobes that are divided by the sylvian fissure. So here's your temporal lobe, and here's your parietal lobe. Same thing on this side. Temporal lobe, parietal lobe, sylvian fissure. Your cerebral cortex is kind of like the crust of your cerebrum, and we can see it when we take this model apart this way. It's going to be this pinkish part. So that's your cerebral cortex. Okay? The sulci is the grooves, so the lines, the indentures, while your gyri are the bumps, so the little mountain area of your brain. The longitudinal fissure is what divides the two hemispheres, right down this way. Your transverse fissure divides your cerebellum from your cerebrum, and this doesn't have good wires, so right there. So this is your transverse right here. Yes, good, good, okay. After that, you have your corpus callosum. So now we're going into the seahorse. It's a Mexican seahorse, so it has a sombrero, and that's your corpus callosum. After that, Mexicans have big eyebrows, so this is the eyebrow of the seahorse, and that is your fornix. After that, you have your sylvian fissure. I already pointed that one out. Your lateral ventricles won't be seen on this model. We're moving into the diencephalon. So that was all the cerebrum. In the diencephalon, we have the thalamus, which is this area around this eye of the seahorse. And then you have your hypothalamus, which, if you could divide this in half, is the snout front area, the mouth area of the seahorse. Then you have your interthalamic adhesion, which is the eyeball of the seahorse. Seahorse is male because male seahorses get pregnant. So it has an Adam's apple, and this Adam's apple is your mammillary body. After that on your list is your infundibulum, which is this white wire. Change angles. So this white wire is your infundibulum, which attaches the pituitary gland, which is this bean. The seahorse is snacking on something, so it's got its mouth open around a little snack, and that right there is your optic chiasm. And then on the back of the head, the occipital region of the seahorse, is your pineal body or pineal gland. Next, we're moving on to the mesencephalon. For that, we're going to take both sides of the brainstem so that we can see the corpora quadrigemina. And quad being 4, you have 1, 2, 3, 4. The two top ones are your superior colliculi, while your two bottom ones are your inferior colliculi, and together they form the corpora quadrigemina. Next, for the mesencephalon, is your cerebropeduncles, and it's these little lines that are found on the sides. It's better seen on this side, and they're kind of wrapped around by cranial nerve number 4, so that kind of helps you identify it. But these lines are the cerebropeduncles. After that, we move into the metencephalon, which we'll use the numbered side. Includes the pons, which is the pregnant belly of the seahorse. and the cerebellum, which is this part that wouldn't stay together. In the cerebellum, we have the vermis, which is going to be this backside, also considered the butt crack of the cerebellum. The vermis divides the cerebellum into two sides, two hemispheres. So you have your left and your right hemispheres. Then when you split it, you have your cerebellar cortex, which is all the brown area, everything that's not white. So this is the gray matter. And then you have your cerebellar white matter, which is the white part that kind of looks like a tree, also known as an arbor vitae. Finally, you go back to this part, which is the myencephalon, and that is going to be this last little bump right after the pregnant pons of the seahorse. This little bump here is your medulla oblongata. That's it for that.